Hello student, and welcome to the course Urban Rail Transit Tracks, Stations, and Yards. The last lesson revolved around how to improve defects caused by traditional railway joints. And this time, we're going to start off a new components from superstructure of the railway tracks. In the early days of railroads, particularly around 190 years ago, the construction of railway tracks was quite different from modern methods. This use of individual heavy stone blocks to stabilize the tracks was a prevalent technique during that time. The method, known as a stone block track, involved laying tracks on carefully cut and positioned stone blocks, which acted as a solid foundation for the rails. And this is where the sleepers stem from. So what are sleepers? Well, sleepers, also known as ties in North America, are rectangular or trapezoidal support structures that have an important role to support the rails and keep them at the correct spacing and level, providing a stable base for the rails. By using sleepers, vertical forces and loads from the rail can be absorbed and transferred into the track bed. In addition, horizontal forces from the transverse Henle oscillation to the track, centrifugal forces in the curve, and the longitudinal forces during braking and starting of the track are also transferred by sleepers. To make it easier and faster to build railways, transverse sleepers made of wooden beams of logs were then used in shapes such as rectangular, triangular, half-round, and trapezoid. As railway begins to expand during the 19th century, cast iron sleepers gained popularity. They were relatively durable and could support the weight of trains. And today, those sleepers can only be seen in few countries. With the evolution of the railway industry, various primary types of sleepers are developed and utilized globally. There are wooden sleepers, concrete sleepers, steel sleepers, and composite sleepers. In this lesson, we're going to find out characteristics of wooden sleepers. Engineers have traditionally tried to make the utmost use of any raw materials near the work in progress. The obvious choice for sleepers are timber, and for over 100 years timber was principal rail support used throughout the world. That's why wooden sleepers, also called timber sleepers in some countries, are the traditional type of sleeper, and they are still widely used in the railway construction. A wooden sleeper is prismatic in shape, 15 centimeters high, 25 centimeters wide, and 2.6 to 2.7 meters long. They are relatively lightweight, weighing in about 100 kilograms. And that means the sleeper can be easily replaced and quickly installed by hand. Wooden sleepers in some countries are classified into two categories, durable and non-durable. Durable type sleepers do not require any treatment and can lead directly on the track. Sleepers produced from some timbers are classified as a durable type, teak, rosewood, burdock, to name a few. Non-durable sleepers require treatment before being put on the track. They are made of wood of trees such as pine, oak, etc. If a non-durable type of sleeper is put onto the track directly without any preservative treatment, the sleeper will be affected by fungi and insects and decay in a very short time. But if such sleepers are treated before use, they last longer and their life is comparable to that of durable sleepers. Wooden sleepers are also sometimes classified as hardwood and softwood sleepers, depending on the origin and the species of the wood of which these are made. Broadly speaking, timbers produced from trees with broad leaves is known as hardwood, and that obtained from the trees bearing long leaves is considered softwood. Some of the hardwood varieties also require treatment before being used in a track. Use is made of the following varieties. Softwood sleeper. As a compressive strength perpendicular to the wood grain, the case of the softwood is not great. A steel base plate has to be placed between sleepers and the rails to spread the load over the greater area. In the long term, however, the base plate cuts into the sleeper wood, causing a gap into which water can penetrate, resulting in rapid deterioration of the quality of the fastening. This phenomenon is slowed down by treating the bearing surface of the slipper with a synthetic material, which can increase the service life of the slippers generally by 50%. Hardwood slippers. This type is stronger and has a longer surface life. Hardwood slippers are used, for instance, in switches and crossings, and where fastenings are applied without base plates. As a result of high mechanical stresses and their low strength, softwood slippers can no longer be used. That's why wooden slippers are nowadays widely made of beech or oak wood. Once the wooden slippers are delivered, they undergo a series of treatments before they can be placed in a track. These treatments include a drying period at least 9 months, during which the moisture level decreases to 20 to 25% of the wood's dry weight. The slippers are processed through notching or milling of the bearing surfaces, drilling a hole for fastening, and binding using a steel band to prevent cracks. Additionally, a special chemical substance called creosote, which is a coal tar pyrolysis derivative with very effective and long-lasting pesticide impact, will be used. The slippers are treated with creosote under high pressure to protect against biological threats like fungi and insects. Then the creosote is infused into the wood with some oil recovery through the vacuum application. Finally, the fastening system is securely fixed to the slippers. The wooden slipper out in the track are continuously exposed in constantly changing moistures and dryness, which is why they should be impregnated in the water and insect repellent materials to provide protection and prolong their surface life. There are several methods for the treatment of timber slippers, the most common of which involves impregnation under pressure. The lifetime of wooden railway slippers varies based on the type of wood utilized. For oak and beech timber that has been treated, the lifespan around 25 to 30 years respectively. Non-treated Azube typical timber lasts approximately 40 years, while treated Azube tropical timber can endure for up to 45 years. In the case of hardwood like Jarrah, commonly employed in tunnels, the slipper can last around 50 years. This duration indicates how long the slippers can function effectively before needing replacement, with factors like wood type and treatment influencing their longevity. Wooden slippers come with a set of notable advantages and disadvantages. On the positive side, they offer several benefits. Firstly, they are cost-effective and straightforward to manufacture. They excel at absorbing shocks and have the ability to dampen vibrations, which helps to retain the track's packing efficiency. Wooden slippers work well in areas with yielding formations. They also allow for easy alignment correction and are better suited for modern maintenance methods. Additionally, they provide good insulation against the signal currents for track surface sections. Further advantages of wooden slippers include that lightweight and favorable elastic behavior when under load. They can be reconditioned within the track at any time, and quick replacement are possible even during brief operational breaks. However, there are certain downsides to using wooden slippers. This short lifespan is a notable drawback due to the water, decay, vulnerability to vermin attacks. Mechanical wear caused by bitter packing is another concern. Maintaining a consistent gauge can be challenging with the wooden slippers, and they are also susceptible to fire hazards. Weather-induced rot poses a significant risk as well. Also, wooden slippers are vulnerable to stress and moisture. In this lesson, we explored the importance of slippers in the superstructure of the railway tracks, particularly focusing on the wooden slippers. Slippers serve as crucial support structures for railway tracks, maintaining proper spacing and stability. Wooden slippers are lightweight and come in durable and non-durable varieties. They undergo treatments such as drying, notching, creosote infusion to enhance durability. The lifespan of wooden slippers varies by wood type and treatment, ranging from 25 to 50 years. While wooden slippers offer cost-effectiveness, vibration damping, and alignment flexibility, they have downsides like shorter lifespan, susceptibility to decay and vermin, and the challenges in maintaining consistent gauge. Next time, we will delve into concrete slippers and steel slippers, exploring their characteristics and advantages in rail-track construction. These alternative slipper materials have their own unique features and applications in the modern rail infrastructure. Stay tuned to learn more about these crucial components of the rail superstructure. See you next time.